Jai Hind to all. I am Dr. Saroj Kushwah, Department of CAC from Ajay Kumar Garinji College, Ghaziabad. Today I will discuss on the topic graph and its type. Graph. A graph is a non-linear data structure that consists of vertex and edges. Vertex is also called node or object in a graph, and an edge is used to connect two vertex with each other. Graph are non-linear data structure allows us to have different paths to get from one vertex to another vertex, unlike the data structure like array or linked list. Types of graph. There are different types of graph in data structure. First one is weighted graph, directed graph, undirected graph, connected graph, cyclic graph, loop, etc. First, weighted graph. A graph is a graph where the edge have values. The weight values of an edge can represent things like distance, capacity, and the probability. Connected graph is when all the vertex are connected through the edges. Somehow, a graph that is not connected is a graph with isolated or disjoint subgraph or single isolated vertex. A directed graph, also known as a digraph, is when the edge between the vertex pair have a direction. The direction of an edge can represent things like hierarchy or flow. A cyclic graph. Cyclic graph is defined differently depending on whether it is directed or not. A directed cyclic graph. Directed cyclic graph is when you can follow a path along the directed edge that goes in circle. Removing the directed edge from F to G in a animation ever makes the directed graph not cyclic anymore. An undirected cyclic graph is when you come back to the same vertex you started at without using the same edge more than once. You cannot define the one edge more than one edge. The undirected graph above the cyclic because we can start the end up in the vertex C without using the same edge twice. Loop. Loop is also called as a self loop of any vertex. The self loop is an edge that begins and ends on the same vertex. A loop is a cyclic that only consists of one edge. By adding the loop on vertex A in the animation above, the graph becomes cyclic. Means loop means suppose here is A, then edge connect to the same thing. It is same vertex. It is called a loop. Weighted graph. Weighted graph is a mathematical structure that extends the concept of traditional graph. It is a extend version of a concept traditional graph by assigning numerical value known as weight to its edge. In the weighted graph, we assign the means either distance or their distance and their weight or capacity to each edges. These weights represent various attributes such as distance, cost, time, enabling the modeling of complex relationships and facilitating the solution of optimization and pathfinding problem in various fields. In this mathematics article, we will explore the weighted graph in graph theory along with its type, application, and weighted graph example. Then what is weighted graph? Remember that graph comprise nodes and edges, with each edge denoting linking between two edges. In the case of weighted graph, in a graph theory, each edge assigns the numerical value. The numerical value we called as a weight. The numerical value, we kept the numerical value between the two edges. It is also called as a cost, distance, or time, etc. The graph consists of 5 nodes. Here is the graph which is consist of 5 nodes 0, 1, 2, 3, 4. Each has weight. The example, the age from 0 to 3. Age from 0 to 3 has weight 7. 1 to 3 has weight 4. 0 to 1 has weight 3. 1 to 2 has weight 1. 4 to 3 has weight 3. And 0 to 4 has weight 8. And 2 to 3 has weight 2. Where the graph frequently serves as the means to represent tangible entities and the connection among them. The instance of this can be found within the framework of Google Map, where cities represent the node represents the city, and road stands as a edges. It is represent the cities and the edge represent the road stand. As age, and the age weight signify the time or distance between two cities. The previous illustration present the weighted undirected graph. Characteristics by undirected edges. However, it is important to note that weighted graph can also exhibit directly. Presented below is an example of the directed graph. This is the directed graph. Directed graph and weighted directed graph have practical applications such as modeling real process. The application is modeling real process. In this concept, consider node 0. Consider node 0 as a storage location where resource need to be transferred to the node 2, while the other nodes serve as intermediary. This node serve as a intermediary. The age indicates the direction of resource transfer, with age weight represent the maximum allowable resource transfer capacity. Note, please be aware that the provide example all the weight are positive. Here the all you can put all the weight positive, not the negative or any sign or any type of symbol. But it's important to acknowledge that negative and zero weight are also permissible. There are different types of weighted graph. Weighted graph are specialized type of graph where each edge is associated with numerical value or the weight. These weight can represent various properties such as distance, cost, time, and they play the crucial role to solve the real-time problem. Here are main type of weight graph: directed graph, undirected weight graph, positive weight graph. In a directed weight graph, the directed weight graph also known as the digraph, where the edge have direction. That is, they go from one vertex to the another, and the direction matter. Directed weighted graph are commonly used to model relationship with one-way flows, such as road network with traffic direction. Undirected weighted graph. Undirected weighted graph are similar to directed graph, but the edge do not have a direction. In undirected graph, edge does not have a direction. The relationship between vertex are symmetric. These graphs are often used for modeling scenario where relationships are mutual, such as social network. Positive weighted graph. In a positive weighted graph, all edge weights are non-negative number. These weights typically represent distance, cost, or durations. Positive weighted graph are prevalent in application like GPS, navigation, logistic, and network routing. Negative weighted graph. In contrast to positive weighted graph, negative weighted graph allow edges to have negative weight. Here the age between the two vertices are negative. Negative weight can represent benefit or saving. The weight which are given between the two ages are represent the savings. This graph find applications in problem like profit maximization, minimization, expenses, and certain game theoretic scenario. Mixed sign weighted graph. Mixed sign weighted graph have both positive and negative age weight. They can model situations where there are cost and benefit associated with the different ages given in the graph. Mixed sign weighted graph that have both positive and negative values, positive and negative weight. They can model situation where there are cost and benefit associated with different ages. Example include scenario where one need to balance trade-off between cost and benefit. Complete weighted graph. A complete weighted graph is one in which an edge connects every pair of distinct vertex. In other words, there are edges between all positive pair of vertex. Complete weighted graphs are often used in optimization problems such as the traveling salesman problem. This is the application of the complete weighted graph, the traveling salesman problem. Bipartite weighted graph. Bipartite weighted graph has its vertex divided into two disjoint sets or the edges. Only connect vertex from the different sets. Bipartite graph are used in scenarios like machine problem where you aim to pair element from one set with element from another set optimally. Application of weighted graph. There are different applications of weighted graph across various fields due to their ability to model relationship with associate numerical value. Here are some key applications in short points. Number one, GPS navigation. Weighted graph used to calculate optimal route, taking into account factor like distance or the traffic conditions. Network design. Weighted graph help in design efficient communications and transport networks, minimizing cost or maximizing the performance of any uh, applications. Social network, the power friend recommendation by analyzing user interactions and common interest. Financial modeling, in the financial motivated graph assists the portfolio optimization by evaluating correlation and risk between assets. Robotics. Robots used weighted graph for path planning to navigate through complex environment. Game development. The weighted graph is used for game development, weighted game development and game maps, AI decision making, optimizing player experiences. Next, the computer network. They help manage data, traffic, optimize routing, and ensure network reliability. Next, transporting planning. Public transportation system like utilizes graph to schedule routes and minimize travel times. There are different algorithms which are used to define the weighted graph. Uh, First, Dijkstra, Prism, and last one is a Kruskal algorithm. The objective of Dijkstra algorithm is find the shortest path from specified source vertex to all other vertex in a weighted graph. Prism algorithm for minimizing spanning tree. Objective, find the minimum spanning tree of weighted connected graph. Kruskal algorithm. The objective of Kruskal algorithm find the minimum spanning tree of weighted connected graph. Advantages and disadvantages of weighted graph. Weighted graph which assign numerical value weights to age have both advantages and disadvantages depending on the context in that they are used. Here the explore pros and cons of the weighted graph. Advantages of weighted graph. There are different advantages of weighted graph. First one is a realistic modeling, second optimization, third precision, and fourth one is the complex relationship. First, realistic modeling. In a realistic modeling, weighted graph allow for more accurate modeling of real world scenario where relationship have varying strength or cost. Optimization. They are essential for solving optimization problems such as finding the shortest path or minimum spanning tree. Precision. Age weight provide precision information making weighted graph suitable for application like GPS navigation and financial modeling. Complex relationship. They have represent complex relationship including negative weight which is crucial in certain context. Disadvantages of weighted graph. There are different disadvantages of weighted graph. First one is the increased complexity. Second, computationally intensive. Third, data overhead. Fourth, limited applicability. First, increased complexity. Weighted graph are more complex than unweighted graph, which can make algorithm and analysis more challenging. Next, computationally intensive. The another disadvantages of weighted graph the weighted graph is some algorithm for weighted graph like finding the shortest path in a large network can computationally intensive. Here the next then another is the data overhead. The in a data overhead, weighted graph assigning and storing age weights can introduce data overhead, especially in dense graph. Limited applicability. Another disadvantages of weighted graph is limited applicability. Weighted graph may not be suitable for all the scenario as not all relationships have qualifiable weights. We hope that this weighted graph can be understanding and exam present. Stay tuned to here. We give the different textbook app for more updates and related this topic from the mathematics and various such subjects. Okay, thank you.